Thank you. Okay, so I mentioned it earlier when we introduced ourselves here all together. Unified automation is like the core of a lot of OPC UA products, especially on the controller level. We have a huge market share there for the vendors that use OPC UA, implement OPC UA. A lot of them are based on our C or C++ based SDKs. We have different programming language, and as Juni already said, we cooperate with Process, and so we just resell their Java SDK. And we have, like I said, our biggest portfolio is in the embedded range or C, C++ based, but also .NET SDK. I will explain in my presentation what we did already to make the implementation of OPC UA FX easy or possible. And that's a step-by-step, and it also is based on the principles of OPC UA and the architecture of OPC UA. That's my main scope for that presentation. So if we talk about OPC UA and how you implement OPC UA and what OPC UA provides as a platform, we have a lot of functionality that is very generic. So independent of any information source of any product, it's just a basic modeling language, services to access the data, different protocol bindings to actually communicate over the network. And that's the part that you can put into libraries and make available to people that implement products. So our business is to make it easy to implement OPC UA, especially easy to start with the implementation. That's our task. And probably, Juni, that's also what you confirm for what you try to do, is like make it easy to implement OPC UA. There's always, if you do like a complete process management system, there's maybe more work to do long term. But to get started, it's always important to have simplification and make it easy to implement OPC UA. And then we have all these information models that use these basic constructs. And we have tooling to make it easy to even build. So a lot of the working groups use our tooling for creating this information models in a machine-readable format, in a node-set format. But also, the tool also is able to create code for the SDKs. So especially if you develop a server, and especially for rapid prototyping, it's very useful that you create out of the, let's say, OPC UA classes, you create really programming language classes, and you can implement the business logic very easy in the first step. For prototyping, maybe some of the functionality you can keep in this way. Others you maybe need to have a more generic mapping to the actual product. So what our SDKs do from like a long time is to cover this case of like this generic OPC UA functionality, and then you integrate your product-specific data, do the business logic integration with the product that provides the OPC UA interface. And like I said, we have the UA modeler. You can take either standard models as input or application-specific models or both. And you can create code out of these models and use this code to build your product-specific integration. So that's nothing new. That's what we do like more than nearly 15 years now. Then we added in the OPC UA picture, like 5-6 years ago, we added this pop-sub functionality. So complete new communication pattern, but that still fits in the overall architecture. So the basic idea is that you really work on this information model here. That's what you do for energy, and that's what you do for process. Like that's how you define also the mapping of your product to the OPC UA server address space. And the rest down here is more or less done by the libraries that do the communication. So the idea with PubSub in the architecture was always, you don't need to change anything in your information model to send also data via PubSub. And that's also what we like, how we implemented our SDK extensions for PubSub is, you have additional functionality that you need to integrate from the SDK, but your product integration here does not change at all. So you just add additional library that you link to your application, and then you have PubSub. That's not totally true, because when we talk about real-time data, you don't want to send the data through all these layers up and then down and then out to the network, because that kills the real time. But it's the same idea of in the first step, you can just add PubSub without any additional code. But then if you want to optimize your product, then you can also do direct data integration to have cover these real-time use cases and be more efficient. So this is something we have now in all C++ SDKs as released versions. And that will also be in the .NET SDK coming soon, end of the year. So then we have this covered PubSub functionality in all the SDKs. And now the question is, what is FX adding? So there's a lot of it happens on the information model level. So you have an automation component. That's the basic concept of OPC UA FX. You have an automation component, and then these automation components could be like controllers, could be devices, could be like edge devices, any application, and then you can establish communication between these automation components. And the automation component consists of some asset information. This is pure information model. And then some functional entities with input data, output data, configuration data, and also identification. And also, most of this is also pure information model. So in this picture, this is all information model. And only if we talk about how these automation components, functional entities talk to each other, then we have PubSub functionality. So if you think of a logical connection, and that's the crazy stuff is with client server, we have a close connection between client and server. With PubSub, we decoupled both applications, and with FX, we coupled them back again. But the reason is, with client server, you cannot reach the real-time capabilities. So we have already customers that do this kind of communication in the microsecond range. There is no way to do that with client server, no way. And so you need the planning capability, the scheduling capabilities of PubSub to do this real-time communication between the functional entities and the automation components. We have there's different types of connections. So you have if both components have inputs and outputs and they exchange them, you have bidirectional communication. Then there's the option to have only data flow in one direction and then heartbeats in the other direction. I think the first two will be the common use cases for FX. So I think that's the common use cases. Because these two are more like plain PubSub. So you don't really need FX for these two here. But it's to cover the different variations, it's still in the picture. But the left two are, I think, the common scenarios for FX communication. Because even if the data flows just in one direction, the other side still wants to know if the communication partner is there and is connected logically. Okay, so in the big picture, in the architecture picture, most of the FX stuff is on the information model level. So all the connecting devices, base information model, also I/O motion instruments. And I think if we talk here about this layer, there is some definitions also in FX or referencing standards, but in the architecture picture of OPC UA, I would say most of the functionality is up in the information model. And that's why we the key feature for adding OPC UA FX into a product is to have pop-sub already in. So if you don't have pop-sub functionality implemented, the FX part is you need pop-sub to make FX possible. So what our FX extensions do to the SDK, they more or less use the pop-sub stacks as they are, and they are more or less exposed like the functional entities and the asset information as a pure information model functionality. That's something the SDKs can do since 15 years. And then you have this connection establishment, the actual cyclic communication. This is then more or less creating input to the pop-sub configuration. That's why this connecting devices goes also into the pop-sub layer, but mainly on the configuration. So it's just another way to put communication objects into that pop-sub configuration. And that's why we have a lot of customers that already have implemented pop-sub and they test and release pop-sub before they even start FX, because that's the baseline for everything. And now like I said, we have FX functionality in two SDKs, high performance SDK and in the C++ SDK. That is currently beta versions that we provide to customers already for demos. So did you show the demo wall in your presentation? Yeah. So if you have seen the demo wall in Peter's presentation, I would say 80% of the controllers use our SDKs there, either C++ or NCC for the demo. And we will have FX integration as part of the next releases of the SDK. So high performance SDK and C++ SDK will have like that as a regular product extension in the next release. So if we look at the big picture, and that's, like I said, again, is more like to get quick started. If you at the end develop a product, there's maybe different optimizations you want to do, but the basic idea is you take information models as input, like OPC UA FX model, device-specific model. You can create code for the SDK to expose like all the FX-specific information as instances in the address space of the server. And that's all pure SDK functionality that we already have since 15 years, nothing special. And then you create a first FX automation component, and then we have an OPC UA FX connection manager implementation in our UA expert. So we have already a pop-sub configuration capability there. Since version 1.7, it's also compliant with the latest OPC 105 version of the pop-sub configuration. And we added also OPC UA FX configuration in there. That is at the moment also available as beta version, but will be also available in the next 1.8 release. And then you can do the communication testing between automation components with UA expert. Okay, that's my update on the SDKs for OPC UA FX support. Questions?